In 1942, in a remote valley on the Crimean Peninsula, the ground shook not from an earthquake, but from the appearance of the most absurd machine. It was the Schwerer Gustav, or, as the Nazi soldiers called it, Dora. This was no ordinary cannon. It was a colossal mobile steel fortress, the largest piece of artillery ever, deployed in the entire history of human combat. The sole objective of this mechanical monster was to crush the fortified underground defensive system, constructed of multi-layered reinforced concrete, of the Soviet Red Army at Sevastopol. Forget the ordinary field guns you've seen in movies. To move Dora to the front lines, the Third Reich couldn't use trucks or trailers. They had to deploy precisely 5 specialized trains, lined up for miles, just to carry the disassembled parts of it. The logistical load was insane. The German army needed over 4,000 soldiers, including medical engineers, ballistic specialists, artillery, and combat engineers, just for the pre-deployment process. While a Pak-40 anti-tank gun only took a few minutes to clear a firing range, Gustav's crew spent a full 6 weeks sweating and bleeding under the brutal pressure of wartime, just to prepare a single firing position. Why did it take 6 weeks for a single gun?
Get those crates secured!
The answer lies in its physical scale.
Check the elevation mechanism.
20th century
Report status on the rear coupling.
The bore diameter is inconsistent here. It is within the margin. Prepare for the next stage of assembly. Understood.
Built by the infamous Krupp Heavy Industries Corporation, under the direct supervision and guidance of Chief Engineer Gustav Krupp himself.
Zieht die Holme
When
auseinander!
fully assembled on the launch pad, the total
Jawohl, Herr
length of this
Unteroffizier.
deadly machine
Feuerstellung!
reaches an unimaginable 47.3 meters, equivalent to 155 feet 2 inches. Imagine taking 8 American M4 Sherman medium tanks lined up in a straight line. This mass of metal would barely equal the length of this super cannon alone. The heart of the machine, the barrel, is an unprecedented metallurgical marvel. It stretched 32.5 meters, equivalent to 106 feet 8 inches, tearing through the sky like a giant spear defying gravity. The nominal caliber of this tyrant was 870 millimeters, or 31.8 inches. The barrel was machined with intricate spiral rifling force, a massive projectile to spin, cutting through the air and stabilizing its trajectory. Initially, the depth of the rifling was, this was machined to approximately 1 centimeter, or about 0.4 inches. However, the intense dynamic friction and the combustion chamber temperatures reaching thousands of degrees Celsius after continuous firing rattled the metal. These grooves wore down rapidly, pushing the fatigue limit of the steel to its peak. As a consequence, by the end of the campaign, the overall internal caliber had been enlarged to over 817 millimeters, 32.2 inches. Furthermore, the chassis and undercarriage of the gun had a width of up to 7.1 meters, approximately 23 feet 4 inches. This oversized horizontal dimension exceeded all railway measurement standards in the world. Therefore, the gun was completely unable to stand on a single rail system. Engineers were forced to build 2 pairs of parallel rails, forming a super-wide double rail system just to bear its distributed load. When the gun barrel is lowered completely to the horizontal loading position, the highest point of this steel structure reaches 11.6 meters, approximately 38 feet 1 inch. To put it simply, this height is equivalent to taking 4 M4 Sherman tanks and stacking them on top of each other using a crane. Gravity then becomes a matter of life and death physics. The solid steel gun barrel assembly alone weighs 400 tons on the pivot system. The total weight of the entire machine when in combat mode reaches 1,350 tons. This is heavier than a fully loaded civilian passenger train. How can you assemble a 1,350-ton steel structure in the midst of a bomb-strewn battlefield? To move the machine, engineers at Krupp designed a complex modular disassembly mechanism, breaking the cannon into approximately 25 main structural components. The field deployment was a construction engineering nightmare. It all began with the engineering corps having to level an entire hillside and excavate the ground to build 4 railway lines. A completely new parallel system. The 2 central rails served as load-bearing supports for the cannon itself. The 2 outer rails were designed exclusively for giant cannon cranes, manufactured by Recoil. These cranes moved along the outer edge of the battlefield, roaring and spewing smoke, lifting and lowering hundreds of tons of steel blocks into the correct locking joints. The recoil pressure of an 800mm caliber weapon was a shockwave capable of tearing apart the Earth's crust. Therefore, reinforced wooden sleepers beneath all 4 rails could not be placed at the usual distances. They were pressed tightly together and simultaneously reinforced and sealed underneath by a network of ultra-thick iron mesh plates. This structure acted as a giant shock absorber, absorbing kinetic energy and dispersing the shockwave transmitted to the dead ground each time the cannon fired. The assembly process was a rigorous mechanical dance, requiring approximately 250 mechanics and specialists working simultaneously with extreme concentration. First, the left and right halves of the chassis were shaped on roller systems. Each half of the chassis rested on 4 steering assemblies, each containing 5 wheel axles. This meant that this death machine moved on a total
Check the hydraulics
of
on level 2.
steel axles, equivalent to 80 independent train wheels.
Pressure stabilizing now.
The steel rails day and night under the weight of thousands of tons. As soon as the wheel system was in place, a connecting block, the central and base mounted assembly was lowered to the range, locking the 2 halves of the chassis together into a solid platform. Next, the trough-shaped gun mount was lowered into the base. This mount was not welded in place, but was suspended in a sophisticated manner on 2 enormous horizontal pivot pins, precisely positioned between the 2 U-shaped beams of the upper support base. These 2 pivots are the dynamic balancing points, allowing the hundreds of ton steel mass to stand tall. Immediately afterward, the load-bearing outer casing is placed in the support, awaiting the most crucial component. The gun barrel cannot be cast as a single piece. It consists of 2 main parts locked together by a threaded connecting hook the size of an entire room. The rear half of the gun barrel slides deep inside the outer casing. To counteract the recoil technique part, 4 enormous hydraulic recoil damping cylinders were arranged in 2 pairs, tightly embracing the gun mount, neutralizing destructive kinetic energy of the chassis. Finally, the massive breech block was installed. Behind the machine, a welded loading platform was assembled. This platform housed 2 high-powered lifting winches, an independent generator, power supply, and a central tray equipped with a specialized hydraulic projectile ejector. The cannon was complete. However, the most terrifying thing was not the steel casing, but the enormous projectiles, the size of a double-decker bus waiting to be loaded into the combustion chamber. The system was silently charging. The air was thick with the smell of diesel fuel and the sweat of thousands of mechanics. Providing enormous power. Alive of the entire lifting winch system and hydraulic mechanism, an independent diesel-electric generator was integrated directly into the machine's base. However, operating a 350-ton machine on slippery steel rails was an extreme frictional challenge. To slow down and stabilize this colossal mass of metal, engineers had to install a specialized train car handbrake system right on top of the front girder of the bogie assemblies. But the handbrake alone was not enough to counteract the impact of 800mm caliber explosion. Before firing, the enormous solid steel A-frame supports, or jacks, were activated to lower the chassis and plunge deep into the ground. These hydraulic jacks acted as physical anchors, directly transmitting the entire terrifying recoil force of thousands of tons straight into the Earth's core, thereby saving the wheel axles from immediate shattering and simultaneously locking the machine in place, absolutely preventing lateral sliding that could have altered its coordinates the moment the projectile left the barrel. Once the platform was locked down, the massive projectile began to open. The shorter Gustav finally spewed out 2 types of destructive artillery shells, a series of individually designed physical targets. The first type is the high-explosive projectile, called Sprengstoff in German. Although classified as a lighter version, its size still exceeds the imagination of conventional military thinking. When combined with all the propellant charges, the total length of this projectile reaches 8.26 meters, approximately 27 feet long. This size is equivalent to fitting an entire red double-decker bus into the combustion chamber of a cannon. The high-explosive projectile itself is 2.45 meters long, or 11 feet 4 inches, and possesses a bone-crushing weight of 4,800 kilograms, equivalent to 10,600 pounds. It is cast from a super-thick cylindrical steel block, designed to withstand heat, maximum acceleration and cycling. To optimize the air resistance coefficient, a ballistic projectile nose clamp, crafted from silicon, a super-light aluminum, was meticulously fitted into the nose section. This casing cuts through aerodynamic flows, minimizing drag friction, allowing the projectile to maintain kinetic energy and reach unimaginable distances. More importantly, this aluminum cone protected the nose cone located at the top of the steel casing. However, to completely eliminate the risk of misfires in the fierce battlefield, Nazi German engineers added a second backup fuse at the bottom of the projectile. Inside the steel casing was a chemical reactor waiting to explode. The explosives inside weighed approximately 400 kilograms, roughly 882 pounds, a deadly mixture of 2 compounds, oxygen and nitroguanidine. The explosive matrix was meticulously arranged, a highly sensitive hexagen layer is directly wrapped around the fuse. The fuse is triggered by impact. The hexagen will ignite first, creating a wave of extreme temperature and pressure to act as a secondary fuse, detonating the less sensitive but more devastating nitromonidine block. To allow this 4.8-ton projectile to rotate stably in the air, 3 pairs of guide rings cast from sintered iron are tightly attached to the outer ring, accompanied by a soft iron washer located directly behind. When the combustion chamber pressure soars, these iron rings are pressed against the rifling grooves inside the barrel, friction creating a blinding spark,
Push harder!
forcing the projectile to spin rapidly while
Moving!
accelerating
Keep
forward.
going!
Simultaneously, the sealing ring, tightly gripping the barrel, completely sealed with violently expanding gas streams behind it, allowing not a single with maximum propellant, this powerful projectile ejects from the muzzle with a muzzle velocity of up to 820 meters per second, or 2,700 feet per second. It tears through the sound barrier, reaching an astonishing maximum range of 47 kilometers, approximately 29 miles. Impact. Its kinetic energy and explosive force are enough to dig 1-2 meter wide, 1-2 meter deep crater in the ground, easily swallowing an entire multi-story civilian building. But the real nightmare lies in the second type of projectile, the also known as the Panzer Granite, a weapon specifically designed to penetrate underground tunnel systems. Dubbed the concrete piercing shell, this complete projectile is slightly shorter at 6.79 meters, 22 feet 3 inches in length, but it possesses an extremely high density. It weighs a staggering 7,100 kilograms, or 15,700 pounds. A single projectile weighs almost as much as a fully armed Allied P-47D Thunderbolt fighter jet. Its appearance is almost identical to an explosive projectile. Hidden beneath its aluminum tip is a hardened steel point capable of tearing through the molecular structure of concrete. Unlike explosive projectiles, armor-piercing projectiles omit the fuse at the tip, retaining only a single fuse at the base. This design ensures the entire projectile structure is a solid, unbreakable block of steel, maximizing its kinetic penetration through thick armor and concrete. Because the steel can be cast extremely thick to withstand the devastating impact, the space for the explosives was significantly reduced. It only carried about 250 kilograms of explosives, equivalent to 550 pounds. However, when this shell penetrated 7 meters of reinforced concrete, or 1 meter of solid cast steel plate, the explosive charge was activated. The pressure from the explosion inside a bind as sealed and solid space would create unparalleled destructive pressure, turning any underground bunker into a Tal-Dudi eternal tomb. During the Sevastopol campaign, Sheriff Gustav fired a total of 48 artillery rounds at various targets. A Soviet target. One of its most devastating feats was the complete destruction of a massive underground ammunition depot, located 30 meters deep beneath Severnaya Bay, despite its protection by a thick layer of natural rock. However, the era of these colossal machines soon ended with the development of strategic air power and the modern art of mobile warfare in the post-World War II era. The Schwerer Gustav, though an unparalleled engineering masterpiece, possessed fatal weaknesses. Its enormous size made it an unassailable target. Despite careful camouflage, thousands of German anti-aircraft soldiers had to be on duty day and night to protect it from the relentless pursuit of Allied bombers and weapons. Furthermore, the excessively long preparation time and complete reliance on a specialized railway system made the machine completely useless in lightning-fast combat operations, where speed was the decisive factor in determining success or failure on the battlefield. After completing its destructive mission at the Sevastopol campaign, this great cannon was dismantled and transferred to the Leningrad front, but it was never fired again. The powerful counterattack of the Soviet Red Army forced the Germans to hastily retreat, bringing this cumbersome machine back home in utter disappointment. A second cannon, named Dora, was also built and deployed to the Eastern Front, but its fate was equally tragic, having to be withdrawn immediately after assembly. With the collapse of the Third Reich just days away, to prevent these superior weapons from falling into the hands of the Allies, German engineers personally planted explosives to destroy them. Both colossal machines were destroyed. The shattered steel remains of the Schwerer Gustav were later discovered by American soldiers in a forest in southern Germany, while the ruins of the Dora were found by Soviet troops in a different location. These machines, once sowing terror, were now only piles of rusted scrap metal, forgotten amidst the devastation of wartime. Plans to build a third machine, an upgraded version called the Langer Gustav with a longer barrel, and and a longer range, were permanently abandoned when Krupp's factories were bombed. The Schwerer Gustav will forever leave an indelible mark on world military history as a testament to the madness and ambition beyond human limits during wartime. It is the ultimate symbol of a weapon design philosophy that prioritizes absolute brute force, where dictators believed that size and firepower could break any will to resist. Despite its failure to turn the tide of the war, the astonishing technical specifications of this super cannon continue to fascinate historians, mechanical engineers, and military enthusiasts. It reminds us of an era when the limits of physics were constantly challenged and broken, all for the sole purpose of mutual destruction on a massive scale. Today, the remaining fragments of this death machine lie silently in military museums, like steel. Looking back at the Gustav Schwerer, we see not only the greatest metallurgical engineering masterpiece of the 20th century, but also the pinnacle of wasteful resource and human lives in a senseless war. The world's largest cannon roared with the most ferocious roar, and was ultimately buried in the ashes of the very empire that created it, closing a dark chapter of history. Despite its failure to turn the tide of the war, the astonishing technical specifications of this super cannon continue to fascinate historians, mechanical engineers, and military enthusiasts. It reminds us of an era when the limits of physics were constantly challenged and broken, all for the sole purpose of mutual destruction on a massive scale. Today, the remaining fragments of this death machine lie silently in military museums, like steel ghosts reminding humanity of a tragic past. Looking back at the Gustav Schwerer, we see not only the greatest metallurgical engineering masterpiece of the 20th century, but also the pinnacle of wasteful resource, human lives in a senseless war. The world's largest cannon roared with the most ferocious roar, but was ultimately buried in the ashes of the very empire that created it, closing a dark chapter in history. Military museums, like steel ghosts reminding humanity of a tragic past. Looking back at the Gustav Schwerer, we see not only the greatest metallurgical engineering masterpiece of the 20th century, but also the pinnacle of wasteful resource and human lives in a senseless war. The world's largest cannon roared with the most ferocious roar, but was ultimately buried